Can somebody turn the front light off, please, back there? It's one of them. No, the other one. Thank you. All right, so we are recording, so let me get rid of that. Let me get rid of that and bring this back up. And I have to do this, and do this, and do this, and there we go. So now we're talking about frequency distributions. Frequency distribution is a 25-cent word for a table, okay? Blondes, brunettes, redheads, 2 blondes, 3 brunettes, 5 redheads. That is what's called a frequency distribution. It's a 25-cent word for a table, all right? Now, we're not going to do much with tables. You're going to see them. We're going to do later with in Unit 3. We're going to be doing a lot with probability tables or probability distributions. That's what they're called, but they're basically tables. You're going to see a little bit here because we're going to do the mean and standard deviation. Some of you, I don't know if you've ever done that before. I don't know how in depth your 120s are, especially if you go to BFE high school here or another school here. I don't know what, so I don't know. This is a way to organize data. You are used to organizing your data, especially when you're talking about test scores. You know, there are your own individual test scores. But what if we went through the whole class and wrote down test scores? Then we would have to do A's 50, B's 25, C's 36, D's 42. You know, we would have to go through and put how many are in each. So this is another way to organize data. I hate chapter 1 and 2. There it is, a frequency distribution. Frequency distribution is a 25-cent word for table. 25-cent word for table, where you have the categories or classes on the left, and you have the head count on the right. And they're fixing to show you an example. Well, I thought they were. Yeah, they are. There's your M&Ms in a bag. There. That is a frequency distribution. Now, this is a qualitative. Why is it qualitative? Because it's by color. Blondes, brunettes, redheads. When you have a qualitative frequency distribution or a qualitative table, you have categories. So write that down above. You want to write this. You don't have to write the tally marks. You don't have to write that. Just write brown 12, yellow 10, red 9. These are called categories. Now, what's the difference in that and a quantitative? A quantitative, what do you have in boxing, wrestling, MMA? You have weight what? Classes. So in a qualitative frequency distribution, let's say age range, 18 to 22, 23 to 28, whatever the case may be. Those would be called not categories, but classes. All right? So qualitative is category. Quantitative would be classes. And that's your two types of. Now, can you do much math with a qualitative table? No. Somebody tell me how to take the average of brown. You can't. So with a quantitative, we're going to be working with that at the end of chapter 3. Okay? What is a relative frequency? Just mark through relative frequency. A relative frequency, there's the word you're familiar with, is a what? That's a percent. A percent of what? Well, let's say that we take measurements of blondes, brunettes, and redheads in this class. All right, I don't know how many's in this class. I think 26, something like that. So 26 would be your denominator because it's the total. Remember, the total is equal to n is equal to the denominator. And then let's say there's 5 blondes in here. Then that would be 5 over 26. That is your relative frequency. Sometimes I think, you know what I think statistics is? Sometimes I think there was this guy way back in ancient times that couldn't make it as a mathematician. So he thought up statistics and he started renaming everything, complicated names, so it'd make his job sound good. Okay? Because a relative frequency is nothing but a percent. But I don't know why you got to call it a relative frequency. Same thing with a frequency distribution. It's a table. Okay? You'll go throughout this statistics class, you're going to see a lot of words and you're going to be like, why they're calling it that? Like a histogram and a bar chart. Do you know the difference between a histogram and a bar chart? What is it? Histogram bars are touching. That's it. There is no mathematical difference between the two. I think some guy way back said, well, bar chart's mathematical, but in statistics we need to have something different. We're going to call it a histogram. I mean, really, they're not any difference. But you have some people that live and die by this stuff, so... Anyway, relative frequency distribution, we're not going to get into that. But make sure you know how to find frequency. 3 blondes, that would be 3 over 26. 5 brunettes, that would be 5 over 26. Now, if the directions tell you to leave it in fraction form, leave it in fraction form. They may tell you to put it in decimal form. They may tell you to put it in percent. You know, fractions, decimals, and percent, you can write it in any way. Make sure you understand what the directions say. Capiche? Because on the test, they will get you. I'm not going to go over the same thing twice, but I don't know why they're doing that, but anyway. If I wanted to add these up, somebody add those up for me. That's 12, that's 22, that's 28, 37, 40, 45. Somebody add those up for me right quick. See if you get 45. Okay, so N is equal to 45. You need to write that down under your table. N is equal to 45. Now take your handy-dandy calculator. Notice I said you need it, okay? And take 12 divided by 45 and find those frequencies, okay? Or those relative frequencies. Because that's going to be a test question. And they're going to put relative frequency on there. And some of y'all are going to be like, what? Relative frequency is a 25-cent word for percent. So 12 over 20, or 12 over 45, 10 over 45, and so on. And that way you'll have that in your notebook for an example. So you can't say I didn't show you how to do it. And you can just write it as a decimal. Y'all figured out your Chromebooks yet, or they still suck?
They still suck.
Okay.
I can build everything.
You can?
Oh, my cluster work, but I have to go to my hotspot to change my. There's a firewall here, it's not letting me through.
Here?
You go to the internet.
I still think it has something to do with your Chromebook. Because I can go through my phone and use the internet here.
Works, but it's like kids that go to District 3, like we cannot get on the internet here.
I always get the districts mixed up. Which District 3? Is that Crescent?
Yeah.
Okay. Got a lot of friends down that way. I don't tell too many people because they don't want me to tell them I'm their friend. So, you know Coach Gray?
Yes. Yes. Coach Gray.
He's a good guy.
I love Coach Gray.
Does Miss Rainey still teach down there?
Yes. She's got a chemistry teacher.
Yep. Well, a few people down that way. But don't tell them you know me because they won't claim me.
Miss Rainey is definitely good.
Yeah, she's a trip. All right, a bar graph. Here we go. A bar graph. And we're going to compare it to a histogram, which is the same blame thing. So make sure you know the difference between a bargram and a histogram, because that is a standardized test question on any test. Same thing with a pie chart. Make sure you know how to calculate a pie chart, meaning we'll get to one in a second. I'll show you one when we get to that point. But make sure you know how to read them. If you want to add up the bar chart, you add up every one of the bars. If one bar is 6, one bar is 8, then the total is 14. That's how you get the total. Everything is driven by the total. Everything. You can't find the mean if you don't have the total. So you need to learn right now how to find the total of a bar graph, how to find the total of a pie graph, how to find the total of a histogram, how to find the total of whatever. And a lot of people, when I say n, they go, what's n? The total. N is always the total. It's usually always the biggest number. Summation of x is equal to n. The summation of all your grades is equal to, n. So that's the total. And they're going to take this and they're going to, there's a bar chart. Okay? And you got to learn how to read. And I'm not trying to insult your intelligence, but you'd be surprised on how many people I put this test on and I say, what is the total? And they leave it blank. Okay? 12 plus 10 plus what? 9? And then put your numbers up here and then add them up. Plus 6 plus 5 or 3 plus 5. Okay? Make sure you know how to do that. Because any kind of GRE, any type of clinicals, any type of employment, if you go into Michelin or go into Fleur Daniel and you take a employment, I don't know what you call it, test, okay? Then basic knowledge test. One of these questions will be on there. What is this? Is this a histogram or is this a bar chart? How to read this? What is the total? That's the kind of stuff they'll ask, just to see if you know how to read a dadgum graph. Okay? I may ask you that question. I may ask you that question like that on one of my tests. That would be a easy peasy question, but you'd be surprised at how many people miss it. And there's your relative frequency. I'm not going to go over that because we already went over that. I'm not going to go through. I don't know why we're going through that again, but anyway. A Pareto chart. I do not ask you about Pareto charts, but you need to know it. Why? For later. You need to know it if you go into any other statistics course, especially if you go into psychology and you have a psychology teacher that lives and dies. You ever seen one of these psychology teachers that talks about statistics all the time? If you haven't, you will. Okay, there's some psychology teachers, I really do believe that they want to be math teachers. Or, I'm sorry, statisticians, whatever they call themselves. Okay, they want to be a statistician because that's all they talk about. I used to have a couple of instructors at Clemson, and that's all they would talk about. Strange. A Pareto chart is where the bars are drawn in decreasing order of frequency of head count. So the highest, all your Pareto charts are going to look like this, or they're going to look what? Like this. They're either going to be increasing or what? Decreasing, because it depends on how you want it. And that's basically it. In decreasing order, it'll be decreasing. But sometimes they say draw a Pareto chart in increasing order. Sometimes they will do that. There's a Pareto chart. That's the difference between that chart. It's usually decreasing. It's usually a pattern, either decreasing or increasing. That's for your information. Side-by-side bar graphs. Okay, again, I'm not going to insult your intelligence. I think most of you that have had Algebra 1, Algebra 2, and a little bit of probability of statistics can actually read this and say, okay, 0.2, let's say 0.22, that's 0.6, whatever, okay? You can add those up and find out what the addition is or whatever, the subtraction or whatever. You can find the total, okay? I'm not going to spend a lot of time on that, but that's a side-by-side bar chart. So what can you obtain from this, okay? And go back to the original question. It says marital status, never married, married, widowed, divorced. Okay? And then you go back to the right here And there's the relative frequency on never married. So it looks like in 2006, it was up a little bit. Married probably went down a little bit. Widowed, it didn't go down very much. And divorced went up. So what could you ascertain from never married increasing, marriage going down a little bit, and divorce going up a little bit? What can you ascertain from that data? People loving the single life. That's basically what you can tell. Now, it's not much. Why did I not include the widowed in there? Because we don't have no control over that. Okay? We don't have no control over, people died in 1990 and we don't have no control over that. Okay, so I left that one out. But this one, never married, increased. Married, decreased. Divorced, increased. And they're also seeing that with, right now, I saw a report the other day that said that the birth rates are decreasing over the last 30 years. I don't know if some of y'all seen that, but I saw it in a report to the president or something. And it was basically over the last 20 or 30 years, since the 70s or 80s, I can't remember, the birth rates have gone down in the United States. And the average age has gone up. So the average age is going up and the birth rates are going down. First thing I thought of, since it was 70s. First thing I thought of was what? Birth control. First thing I thought of. Why? Because birth control came around, really popularly used around the 60s or 70s. I can't remember. But I think around the 70s. So naturally, something like birth control would affect the what?
Birth rates.
And some other things that I'm not going to get into. But that would affect the birth rate if they're not born. Anyway, horizontal bars, not used very much. They're used in certain, this is for your information. Let's see if they got, there's one right there. Usually you're going to see a horizontal chart when there's a lot of categories. It's a little bit better to show with a lot of categories. Okay? Not a high school graduate, high school diploma, blah, blah, blah. So let's look at this. Not a high school graduate in 1990 versus 2013. High school diploma. It's about the same. Some college, no degree. Associate degree has went up. Bachelor's degree has went up. Professional degree has went up. And this is 1990 to 2013. So what does this kind of tell you from a layperson just looking at it? What does it tell you? People care about school from 1990 to 2013. Is that changing? Yes. I saw another report that talked about, this is the time of year, summer's when we have all these meetings and we see all these reports. People are starting to, and District 3, District 5, and District 4, isn't it? Next door. Do you think that's the only one that went up? No. One went up in Oconee at the same time this one went up. There is a shift. Those people that coming out of Lakeside over here, I call it Lakeside, okay? The Institute of Technology, blah, 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 blah. Some people coming out over here in robotics and mechatronics, they're going to be their first year out of college over at Michelin or Bosch or whatever, making $75,000 up a year. Okay? There's nothing wrong with that at all. And there is a shift. Why else is there a shift? Well, and I'm not biting my own hand because I don't think Tri-County does this. A lot of your technical / community colleges don't do this. But some of your universities are taking advantage of what? Students. They're taking advantage of students, and they're taking advantage of parents, and taking advantage of student loans. What are they doing?
Making college more expensive.
They're making college more open, and anybody can come in, and then they're offering what kind of degrees? Underwater firefighting degrees. They're offering degrees that don't mean squat. Anything that's got studies behind them. And then after the students spend 4 years at a college that they can't afford. I don't know why students want to go to a college they can't afford. But anyway, students do that. They want to go to a college they can't afford. Then they spend 4 years. They spend the first year partying. They spend the first year failing. And then they also spend the first year saying, I can't do math and I can't do science. And then they drop and then they enroll in an underwater firefighting degree, which is global studies or something like that, which has one math class, underwater firefighting math, has underwater firefighting science, and probably has all the easy histories and all the easy Englishes. And then they get a degree. And they got a degree in what? Nothing. And then they try to get a job. And they go into IBM or they go into, I don't know, name a dadgum. They go wherever. And they walk in and they say, what's your degree in? Global studies. Oh, okay, that's nice. Oh, well, don't call us, we'll call you. Whereas there's 3 or 4 out there that's got management majors, business majors, English majors, I don't know, history majors, the bona fide / degrees. Does everybody see what I'm saying? So right now, there is a turn, and I'm seeing it because I saw this turn. I didn't see it. No, I didn't see it because I was a kid back then. Around the 1960s and 70s, there was a turn where everybody needed to go where? To college. Okay? And then, of course, when I was in the 80s, when I was in high school, oh gosh, everybody had to go to college. If you didn't go to college, you were a failure. Okay? Now that's turning. And this is showing it. So, again, knowledge is power. I tell my son, I said, he's very heavy in mechanics. He likes mechanics. Growing up on a farm, it's kind of hard not to. And he likes mechanics and he likes biology. So I know he's going toward the sciences. Okay? But I don't want to hold him down to say he has to go to a certain college because he may not want to pay for college the rest of his life, and I don't want to pay for it the rest of my life unless he's got scholarships and stuff. But the whole point is he's got this place over here now. And that's a great place over there. I went over there. It's real nice. I don't know if y'all seen it. It's real nice. And a lot of kids are going to be helped by that place over there because this thing of you having to go to expensive college and your mom and daddy and you can't afford it, that's old school. Now, there's so many opportunities out there in welding with a welder. I don't know how many of you know a welder. Welder makes a lot of money. He's not respected on the status, but he makes as much as some of those people that turn their nose up at it. Same thing with a plumber. A plumber writes his own check. I mean, a plumber can write his own bill. Have you ever paid a plumber? Yeah. Okay. But that's what that's saying. And I got on a little bit of an advising thing there. Because I don't want anybody telling anybody that they have to do a certain thing. I'm sorry I'm boring some of y'all. Pie chart. Make sure you know how to do a pie chart. There you go. All right, we're going to do an example here while I'm doing it. Let's say that n is equal to 1,000. Let's make it easier. N is equal to 100. So write down n is equal to 100. So how many people were never married? 25 people. How many people were married? 58 people. You take the 0.58 and multiply it by 100. If it was 1,200, you take the 0.58 and multiply it by 1,200. Whatever it, that's why the total drives everything. Okay? The total drives everything. Question. Right. Complaint. Okay, so if I said the n is equal to 1,500, how many people are divorced? You'd multiply 1,500 by 0.11. Now this is going to be on any test that you take. Okay? Because any industry, any business, or any profession, they want to know if you can read a bar chart, and they want to know if you can read a pie chart. So make sure you know how to read one. I'm not gonna get into all this too much. These are just some things. Stem and leaf plots. We're gonna probably go over that next. And then dot plots. Stem and leaf and dot plots are about the same thing. One is with numbers and the other one's with dots. It's not a big deal. Okay, now there's the classes. I told you when you're doing quantitative data, instead of categories, you have what? Classes. So they'll show one here in just a second. So here's the number of numbers. I'm not going to go through this, but 50 households. So write down N is equal to what? 50. So N is equal to 50. There's your numbers. You don't have to write them down, but they go through and they put them in order like that. Now you have a class. The class is on the left. The number of what? Cars. That's your classes. And then, of course, your frequency is 4, 13, 22, 7, and 1. And that's the difference between a quantitative data and a qualitative data. You don't have to write that down. It's just, well, go ahead and write it down because it is the difference between the M&Ms. Go ahead and write it down. Just write down number of cars and frequency. And down at the bottom of frequency, put N is equal to, what was it, 50? So you'll know. And if you want to write down the relative frequency or the percentage, whatever you want to call it, go ahead and write that down. I know that math is not exciting to some of y'all, but like I said, if you want to pass the class, I can read your faces like a book. And there's about 4 or 5 of y'all in here that are telling me y'all want to fail this class by the way you're acting. Remember what I said, if you don't want to be here, don't come. Just watch the videos or Skype in. A histogram is a bar chart where the boxes touch, and somebody made it up a long time ago to make their job feel worthy. That's basically what it is. So let's look at a histogram. There's a histogram. Now I really can't tell you. Let's see what the definition says. Okay, I wish I could pull up the bar chart definition, but I don't. The only thing I see different is the width of each rectangle is the same, and the rectangles touch each other. Now I want somebody to tell me what the difference in a histogram and a bar chart is. I mean, what is the purpose for a histogram? I don't see one, but I'm just a math teacher, so I don't know. I just think that's one of those things that they just made up. Make sure you write down histogram and make sure you draw a picture. There it is. Put it beside the bar chart. If you can figure it out, you can share it to the rest of the class. But I have no idea what the difference is besides they're touching each other. This one is 4. This one looks like 13. That's 17. This looks like 22. That'd be 39. This looks like what? 6? That'd be 55 or 45. Huh? Okay. 43. And that looks like what? 3? That'd be 46. 46, 51. I know it's supposed to be 50, but the whole point is that's how you read. You read it just like a bar chart. For your information, I'm not going to put that on the test because I think it's stupid. Okay, classes, I already told you what classes are. Classes are numbers. Classes are numerical groups. 5'5" to 5'9", 6 foot to 6'4", 6'5" to 7 foot, or 6'9", whatever. Those are all classes. versus blondes, brunettes, redheads. Somebody look at your outline. What sections in 2 are we supposed to go over? I know it's fewer than 1. What is it?
2.3.
2.1, 2.2, and 2.3?
Yeah.
Is that it?
Yeah.
Okay. It's amazing that outline tells you so much information, doesn't it? For the 1 or 2 people that printed it out. And I'm not going to, there's your classes right there. Here's your, see, the first thing you do, now I'm not going to ask you to calculate your classes. Some books get you to do that. I don't do that. I feel like most of the time, especially in this class, this is a class for the person that might present or the person that is presented to. So I don't think you need to go into the mathematics of actually calculating a class. But the one thing I want you to write down on this I want you to write this down, because I'm going to tell you what you can get from this data right here.
So they had to be equal, like same intervals?
Yeah, same intervals. Yeah, we're going to get into that. So write down these classes and call them classes, and then leave the side of the paper blank, because we're going to write down some things you can find here. No sneezing in class. No coughing or sniffing either. Oh, Lord, I'm going to have to hit snooze. I'm going to have to snooze about a third of... Oh, shut up, Hubert. Shut up. I'm going to take the roll. Let me go ahead and take the roll right quick. And I'm not doing that so y'all can leave. So don't do that, because that'll just irritate me. And I'll get pissed off. So don't do that. I just want to get it out of the way so I can tell y'all to get the hell out. Let's see. There you are. I would count everybody, but... What? What is he talking about? Is he on drugs? My cousin Vinny. Are you on drugs?
No, I'm just glad that.
You just happy on you high on life?
I get play football.
Okay. Let's see how many are in here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27. I know that's wrong. Somebody must have added my class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Did somebody add my class? Somebody added. Because there was 26 this weekend. Okay, nobody added, so I guess everybody's happy. Okay. And, okay, yeah, everybody's here. I thought for sure, I must be losing a day. Maybe I lost a day. I thought for sure there was 26 people in here. No, maybe it was Friday when there was 26 people in here.
There's people on Thursday?
Huh?
There's people on Thursday too.
No, I'm talking about, there was 26 people here, but there was 27 on, I thought there was 27 on my roster. Okay, I'll shut up. Anyway, let's go back to boring stuff. All right, so what can you find from this? Well, you can find the most important number, and that's the class width. Write that down, class width. It's the most important number because it's used in calculations, okay? Class width is equal to 10. How do you get 10? You subtract, okay, let me go ahead and tell you what everything is. The numbers on the left are called your lower class limit. So write that on the top of the left. Lower class limit. The number on the right is called the upper class limit. Left, lower class limit. Right, upper class limit. Now, how do you find the class width? You subtract coinciding numbers either on the lower class limit or the upper class limit. Let me show you. What's 680 minus 670? What's 690 minus 680? What's 699 minus 689? That's how you get the class limit. I'm sorry, the class width. All right? Now, why do I not say 670 minus 679? Because you automatically say what? 9. Don't go linearly, go vertically. Because actually, you have to count the 670. You don't subtract. So if you count 670, 670, 671, 672, 673, 674, 675, 676, 677, 678, 679 is 10. The class width is 10, but if you go linearly and say 679 minus 670, you'll get 9 and you'll get it wrong every time. Okay? So don't do that. Go vertically. But don't do 730 minus 670. It's got to be coinciding. It's got to be 679 from 689. 719 from 729. 709 from 719. 700 from 710. That type. It's got to be, one right after the other. Mid-range, write that down. Very, very, very important for chapter 3, the mid-range. Also call it, put in parentheses, mid-range, call it X in parentheses. Because you're going to, later on in chapter 3, you're going to use X for a calculation. The mid-range, right under the mid-range, write midpoint because it's the same formula. The midpoint, or the mid-range, is your lower class limit plus your upper class limit divided by 2. You average the two numbers. 670 plus 679 divided by 2. So write that down in an example. 670 plus 679 divided by 2. Now somebody give me that number. It's going to be a decimal probably. Dang old 674.5. Somebody help me out. Is it? No, you got to add it. It'd be 674.5. Somebody check me. Okay, now write down mid-range is equal to 674.5. Now add 10. What do you get? 684.5. Add 10. 694.5. So instead of calculating each midpoint, what do? You calculate the first midpoint and then add your class what? Add your class width. That's the easy way to do this stuff. So that's why the mid-range and the class width is your most important numbers on a frequency distribution. I heard that. That was yawn. I heard that. That's one. Next. Oh, Lord. I can't believe I did that. I suck. How far was I?
Yeah, we're in
Yeah, I know.
section 2.2.
There we go. Somewhere in here.
Down
My gosh. There we are. Right there. Okay. I'm not going to worry about that. There's your frequency distribution again. I'm not going to worry about that because I think y'all are pretty smart people. Y'all know what a, frequency distribution, frequency. I'm not going to worry about that. There's your lower class limit. I've already went over that. Now, you can look at this, but there's no way in Hades I would give you something like this on a test. Okay? because it takes you half an hour just to do everything. So most of mine are going to be like 4 or 5 classes. So you don't have to worry about that. But that's just a representation of a BA frequency distribution. Lower class limit, and that's where we're getting the class width. There you go. But you don't have to do it that way. You can just look at the first one and the second one and subtract. Them and their histograms. Okay, stem and leaf. Make sure you write this down. I'm trying to get you through chapter 2 as fast as I can because we need to get on the math because that's where most of y'all are going to bog up, even though some of y'all invented it. A stem and leaf looks like this. Well, there's your values. You look at the lowest value you have. Where's my lowest value? You just scan over. I saw that. I see y'all. I see it. 3.2, 2.8. Is there anything below a 2.8? Okay, so 2 is going to be your lowest number. And then your highest number is going to be, I see a 6.9. Just scan over 7.5. So the highest number is going to be 8, probably.
8.5 admission.
Okay, you got an 8.5?
Admission.
Okay, whatever. I'm looking for it. Michigan. Okay, 8.5. So your highest number is going to be 9 because you got to include your lowest number and your highest number. So, and then of course your stem and leaf will look like that. I've got a 2.8, I've got a 3.8, a 3.8, a 3.8, a 3.3, a 3.9, a 3.2. You see? Now, if you look at it sideways, turn it up, and what does it look like? It's starting to look like a bell curve. Okay? A stem and leaf, a dot plot, you will be able to see a bell curve or some type of curve. There's 3 types of curve. What are they? Normal, which this one's not normal, okay, because the 3 is higher than the 7, so it's not normal. It's skewed left. Skewed right, because all the data is on the left. When all the data is on the left, it's skewed right. When all the data is on the right, it's skewed what? Left. Think of it like this. If I give you a test and nobody passes it, then what does that mean? You all suck? No. That means that either y'all suck or I suck or the test is invalid or both or one of the two or two of the, there could be a combination. If everybody fails, then there's something wrong. Okay? Can you tell that to some of these teachers? Hail to the no. They actually think they're doing a good job if you make a 45. I don't understand that. Maybe that's why I'm a math teacher instead of some of these other teachers. But anyway, to make a long story short, what if I give y'all a test and everybody makes 100? I'm not that perfect, and neither are you.
Bad test.
It's a bad test. Okay? So that would be skewed left because everybody would be making a what? 100 on the right side. Normal is what you want. You want something like a normal curve, somewhere in a normal curve, because that means your test is all right. You got some deadheads out there that's not going to listen to me no matter what. Okay? And sometimes I forget stuff. Not a lot, but sometimes I do. I make mistakes. I'm going to be the first one to tell you. Okay? So that's a stem and leaf. What's the difference between a stem and leaf and a dot plot? Well, instead of having an 8 here, I'll have a dot. And then I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9 dots here. And then I'll have 10 dots here. And then I'll have 15 dots here, and so on. That's the difference between a stem and leaf. The main thing is that you see the curve on the side. See it? You see it. That's why you do a stem and leaf and a dot plot. Again, what are these? These are for your information. You might see them on a test, and the test would say, what is this? And then you would have a choice of a dot plot, a stem and leaf plot, a normal curve, or a frequency distribution. And you would pick a stem and leaf. If it had dots, you would pick a dot plot. There's another stem and leaf. Okay? Now, why do they have 2 3s? Because they're splitting above 0.5 and below 0.5. Does that add to the confusion of the stem and leaf? Yes, it does. But some people do it. It's a choice. You know, some people choose bad. Some people don't. Some people do this and it confuses people and some people don't. I just think that's confusing, especially if you're presenting it to somebody. Well, first of all, excuse me, advantage of a stem and leaf diagram over a histogram. A histogram has no meaning. A histogram is a bar chart. That's a stupid title. That just aches for me to say something about it. I'm sorry. I'll shut up. And there's a dot plot. Same thing. Look. Do you see a curve? Yes, you see a curve, but it's a little bit skewed right because the middle is 2.5. And what drives statistics? The middle. Write that down because you're going to see it later in chapter 3. What drives statistics? The middle, the center, the median. All of those things drive statistics. If I gave y'all a test and you made a 78 and the class average was a 42, what does that say? You don't suck. That's what it says. But if I give you the class average as a 46 and you made a 7, you pretty much suck. You got to look at it. Everything's driven around the average, the middle, the median, the center, around statistics. Not probability, but statistics. I saw that.
Yeah,
No, that's all right. That's all right. It's just insulting me. That's all. You're going to fail. Uniform distribution. Uniform distribution is where you cannot control or manipulate the dimension. What is the only thing that we cannot control or manipulate? Good gosh, I feel faint. Somebody actually answered it. Who said that? Wow. You must have heard that somewhere. Wow, that is good, even though some women try to do it. Have you ever been to a recital or a cheerleading competition and the mothers try to dress like the daughters? It's really sad. Yeah, don't do that. Women, don't do that. When y'all get older, don't do that because you look. Only 1% of the population can pull it off, okay? Very few can pull it off, but there are some. But some of them don't need to. Kind of like yoga pants, you know what I'm talking about? And guys, don't be cruising the mall at 40 because that don't work either. So don't be doing stuff like that. Some people try to manipulate time. You cannot. All right? You cannot manipulate time. And we'll leave it at that. Uniform distribution always looks like a box. It looks like a rectangle or a square. And it always has to do with time because that's the only thing, thank God, that we cannot manipulate. We can't touch it. Bell-shaped curve, that's what you want. You usually want a bell-shaped curve because that means everything is pretty much the way it needs to be. Now, did I say that everybody needs to be mediocre? I had a student actually tell me one time after class, you're telling us to be mediocre because the bell curve, you said it was supposed to. Don't you just love people think they know everything? All right, you didn't listen to me. I said that the bell curve is saying that everything is where it's supposed to be. That means the people that study their butts off, they're making what? A's, the hundreds. The people that are deadheads, they're what? Making the S. And the majority of y'all that have jobs, lives, studied when you try to, you make what? 70s and 80s. That's what it's supposed to be. If you make everybody making A's, that ain't going to happen. Now, it may happen in a calculus class. Why? Because those people, as you go up in a math or science or history or whatever, as you start getting on up into the 3 and 4 level courses, what's happening to the deadheads? They're dropping out. Survival of the what?
Fittest.
Survival of the fittest. No matter how much we try to give everybody a trophy, Those guys that win trophies just by participating don't make it in differential equations. They don't make it in physics, light, and sound. They don't make it in a 4-level history or a 4-level English course. Okay? Everybody with me? Even those that are sleeping? I can't believe people are sleeping in my class. I've never had people fall asleep in my class. You're in a very unique group if you sleeping in my class. Skewed right. Skewed right means all the data is on the left. Okay? And if you are making a mark like that in my brain, then don't whine when you make what you make in here. Okay? All right. The skewed right is everything's on the left. So that means everybody sucks, right? You don't want that, do you? Because that means either your test is invalid or it means what? That everybody's not studying, which is why? What's the number one rule, Hubert's rule? There's always what? There's always one person that's going to make 100 on the test. I don't care how bad the teacher is. I don't care how bad the test is. I don't care how bad the class is. There's always going to be one person, oh, I made 100. I made a 98. Dadgummit. And everybody wants to beat the crap out of it. All right? Everybody's going to make. There's always going to be one. If everybody fails that test, the teacher sucks, the class sucks, or the test is invalid. One of those three or a combination of those three. Okay? That is not good. The same thing with skewed left. That means everybody's on the right. That means everybody's making 100s. Now, everybody's not going to make 100 unless I could give y'all a bonus. I could give y'all a bonus question and I could give you a bonus. I did this in my first semester. I gave everybody a pop quiz. The same 5 questions every week, and I still had people fail. When you want to fail something, it's just like when you want to steal something, you want to kill somebody, you want to cheat, you want to fail. If you want to do those things, you're going to find what? You're going to find a way to do it. Period. And yeah, I said kill somebody. Good God, that's what happens. Somebody wants to kill somebody, they go out and kill somebody. Somebody's going to complain and say, I've said go out and kill somebody. I didn't do that. Oh. Some of y'all, there you go. There's 4 examples. It would have been good if they put those on. Anyway, look at that one. Why is a straight line on the first one? Because time cannot be manipulated. It can't be changed. So time is one of the few things that stays the same. Capiche? And the bell shape, that's what it looks like, symmetrical around the center. The center here is 22.5 or whatever. And everything is symmetrical. Now, is it going to be 100% symmetrical? No. But it can't look like letter C and letter D. It can't look like that. So there's your 4 comparisons. Those are test questions. I will test you on those, and you will see this in Unit 3. You will see this again in Unit 3. It's 10 after. Organizing quantitative data. Identifying the shape of the distribution. Okay, I'm not going to go through that. I just went through it. Okay, this is a little bit skewed what? Skewed left. Because a lot of the data is where? On the right. Why do you know? How do you know? You find the center. 670 and 740. 670 plus 740 is 1460. Half of 1460 is 730. 730 is in the middle, somewhere around here. I made 720. But the middle is somewhere right in here. And where is the data? It's on the right. So you got a little bit of a skewed left here. That's the kind of questions I'll ask you on the test. They're easy peasy, but you need to actually pay attention and know what's going on. Okay? If I see something important here, I'll make sure you can read a line chart. Okay? I know they don't want you to know stuff when you get out of high school, like taxes and checkbooks and businesses and marketing and business. They don't want you to know that stuff, but it's very important that you be able to read a line chart. Moving along. Okay, this is very crucial. Misrepresentation of data. This happens. Sometimes it happens by accident. Sometimes it doesn't. Okay? Let me give you an example of when something doesn't. And this actually happened. There was a magazine, and they put this in one of the books we've used in the past. There was a magazine that was doing an article on OIL supply in the United States. Okay? And the guy that did the report, he did the statistics, and he checked the statistics with a mathematician, and they gave it to the graphics person. The mathematician okayed the story and said that the math was correct, but the graphics person screwed it up because the graphics person made the graphics misrepresented the graphics, the numbers with the graphics. That's when something happens and it is an accident. Okay? Sometimes it's not an accident. And that's where you get into the bias again. Okay? You got to look at the two things. There are two good things, the good thing and the bad thing. You got to look at the evil and the good. The good thing is being neutral. Bad thing is being biased. When you're in statistics and probability, that's the two evils. I meant the evil and the good. The good is being neutral. The evil is being biased. When you misrepresent data by using bad graphics, or you misrepresent a poll by not putting the margin of error or the N at the bottom where you can see it, you are being biased, or it's by accident, one of the two. And this is an example of being biased. Okay? If you actually do it like this, you see an increase. But what did you not do? You got to start with 0. Okay? Now, does this increase look as large as this one? No. People can manipulate. I know y'all don't believe that, but some of y'all, when you get into relationships, you'll find that out. Okay, sorry. But manipulation is something that can happen. And this is an example of manipulating a graphic to where you make it look like, oh my God, we're going to die in 12 years. No, you're not. Okay? You'll see this a lot. There'll be examples of this on the test. Make sure if you see them in the book, make sure you make a note of them. If you see them in the homework, make a note of them, because I will ask you these, because I think it's important that whenever you look at a magazine article or whenever you see a poll, you make sure you question it, because knowledge is power, and you don't want to go off the deep end like WYFF does every time a snowflake falls in the south. Okay? Everybody's going to die. That's what they think. I don't know where this is going. Okay, there's a frequency. They're just putting it in a bar chart. Now, first of all, you never want to give a bar chart like this. Why? You can't see the width of the pieces of pie or the wedges. You can't see it. Whenever you do a bar chart, the best way to show a bar chart is slightly 3D or two-dimensional. You never do a bar chart this low 3-dimension. You want to bring it up a little bit so you can see the 3 dimensions, but you can see the width of the what? The wedges. So this is unacceptable. Okay? That's the way you want to do it. Now you can slightly tilt it back, but not much. And you'll see some more. I like to do this is where I like to do it, but I don't really have time because some of y'all are going to start fidgeting in a few minutes. And I don't want to, but I'll show you some. When we get into the book, I'll show you an example with the soccer ball. Right now, soccer ball and OIL barrels. Okay? Soccer ball and OIL barrels. Pronounce it however you like. I'm not going to pronounce it. Write those two down because those two. And also, look for graphs that don't equal what? 100, like on my bonus question. Okay? Anything that doesn't equal 100 is you throw it out the window. Because if it don't equal 100, it's worthless. There it is. Okay. Now, this is what y'all need to be doing over the weekend. Most of y'all have got on to My Labs Plus, but get that done. Read chapters 1 and 2. I don't think you have to send many questions on 1 and 2, but send them if you got them. We're going to start Tuesday, chapter 3. That's where we get into the math. Okay? Y'all have a wonderful weekend. I'm glad y'all got to see me today.